Good day, grade 11 students! Welcome to Bamboo Telescuela. This is your school on air in General Mathematics, and I am your teacher, Kim Francis Season Alam, from Schools Division of Cauayan City, Cauayan City National High School, Maine. Before we begin our lesson, make sure that you are in your comfortable place, can clearly hear me in your radio, and see me in your TV screen. This video is also streamed live in SDO Cauayan City Facebook page. At this point, please get your module in General Mathematics. For the lesson, representing real-life situation using exponential functions. For today's episode, you will learn how to
solve problems involving functions, represents real-life situations using exponential function, and distinguish between exponential function, exponential equation, and exponential inequality. Let us start your journey by recalling the previous lessons you already learned about inverse functions. You have learned from your previous modules the representation of inverse function through its table of values, graphs, and equations. You also learned that a function f is a one-to-one if it never takes the same value twice, or function of x of 1 is not equal to function of x of 2 whenever x of 1 is not equal to x of 2. That is, the same y value is never paired with two different x values. Another, you learned that a one-to-one function with a domain A and range B has an inverse function denoted as f raised to negative 1 with a domain B and range A defined by f raised to negative 1 of y, or inverse function of y is equal to x if and only if function of x is equal to y for any y in B. You learned also the steps in finding the inverse of a function. First, write the function in the form of y is equal to f of x. Second, interchange the x and y variable. Third, solve for y in terms of x. And last, express the inverse as inverse function of x. Let's start your journey by recalling the previous lesson you already learned about inverse function.
The ABS-CBN News reports the foreign exchange rate are closed on March 13, 2020 at 51 pesos and 25 centavos.
Therefore, the formula that gives Philippine peso in terms of US dollars on that day is P is equal to 51.25 multiplied to D, where D represents US dollar and P represents Philippine peso. Complete the table by converting US dollar to peso. For example, we have 1 US dollar, we will convert that to Philippine peso. We will have P is equal to D multiplied to 51.25. We will substitute the value of US dollar, which is 1, and we will multiply it to 51.25. We will get the product of 51.25 pesos. For 10 seconds, convert $25 to Philippine peso. If your answer is 1,281 pesos and 25 cents, you are correct. Convert $50 to Philippine peso. 10 seconds starts now. If your answer is 2,562 pesos and 50 cents, you are correct. Convert $100 to Philippine peso. 10 seconds starts now. If your answer is 5,125 pesos, you are correct. Convert $200 to Philippine peso. 10 seconds starts now. If your answer is 10,250 pesos, you are correct. Another question. Describe how did you convert US dollars to peso? I just multiplied the number of dollars to 51.25 pesos. Third question. Find the inverse of the function to determine the value of a United States dollar in terms of Philippine peso on March 13, 2020. First, we will write our equation, and that is Philippine peso is equal to 51.25 multiplied to US dollar. For us to get the value of US dollar, we will use the division property of equality and we will divide both sides to the equation by 1 all over 51.25. Simplifying our answer, we will get US dollar is equal to Philippine peso all over 51.25. Fourth question, interpret and evaluate function of P of 1000 and inverse function of P of 1000. At function of P of 1000, we will have a new function, and that is P of 1000 is equal to 51.25 multiplied to US dollar. We will substitute the value of US dollar, that is 1000, and multiply it to 51.25. We will get a product of 51,250 pesos. At inverse function of Philippine peso of 1000, we will have a new function. That is, the inverse function of Philippine peso of 1000 is equal to Philippine peso divided by 51.25. By substituting the value of Philippine peso, which is 1000, we will have a quotient of 19.51. Let us start our discussion by definition.
Are you ready? An exponential function with a base b is a function in the form of f of x is equal to b raised to x, where b is greater than 0 and b is not equal to 1. Why is it that the base must not be equal to 1? Because if it's equal to 1 and you will substitute any number to the exponent x, it will be still 1. And that makes the function constant. Example of exponential functions. F of x is equal to 6 raised to x. F of x is equal to 16 raised to x. F of x is equal to 3 raised to x plus 1. What makes the following function exponential? As you notice, the bases of the three functions are all greater than 0 and not equal to 1. And that makes the three functions exponential functions. Let's have an example of the evaluation of exponential function. If function of x is equal to 4 raised to x, evaluate function of 2.
First step is to write the original function, and that is f of x is equal to 4 raised to x. Evaluate function of 2, that is 4 squared, that is equal to 16.
For 10 seconds, evaluate function of negative 2. Time starts now!
If your answer is 1 over 16, you are correct.
For 10 seconds, evaluate function of 1/2. Time starts now!
If your answer is 2, you're correct.
For 10 seconds, evaluate function of pi. Time starts now!
If your answer is 4 pi, you are correct.
The most common application in real life of exponential function and their transformation are the population growth, exponential decay, and compound interest.
Exponential model and population growth. Suppose a quantity y doubles every m units of time. If y sub 0 is the initial amount, then the quantity y after t units of time is given by y is equal to y sub 0 multiplied to 2 raised to t all over m. Example, suppose a culture of 300 bacteria at MGT farm is put into a petri dish and the culture doubles every 10 hours. Give an exponential model for the situation. How many bacteria will there be after 90 hours? At 0 hours, we have the number of bacteria that is 300. At 10 hours, we have a computation that is 300 multiplied to 2 raised to 10 all over 10. Simplifying our exponent, we will have 300 multiplied to 2 raised to 1. Simplifying our term, we have the answer that is 600. We have number of bacteria of 600. At 20 hours, we have our computation that is 300 multiplied to 2 raised to 20 all over 10. Simplifying our exponent, we will have 300 multiplied to 2 raised to 2. Simplifying our term, we will have 1200. Our number of bacteria for 20 hours is 1200. For 30 hours, we have 2400. For 40 hours, we have 4800 number of bacteria. Our exponential model for this situation is y is equal to 300 multiplied to 2 raised to t all over 10. If t is equal to 90 hours, then we will have an equation that is y is equal to 300 multiplied to 2 raised to 90 all over 10. Simplifying our exponent, we will have y is equal to 300 multiplied to 2 raised to 9. Simplifying our right side of our equation, we will have the answer y is equal to 153,600. Exponential decay. The half-life of a radioactive substance is the time it takes for the half substance to decay. The exponential decay formula is y is equal to y sub 0 multiplied to 1/2 raised to t all over capital T. Example, a certain radioactive substance decays half of itself every 5 days. Initially, there are 50 grams. Determine the amount of substance left after 30 days and give an exponential model for the amount of remaining substance. Our pattern formula for this exponential model and population growth example is y is equal to y sub 0 multiplied to 2 raised to the fraction of small t all over capital T. For this problem, your y sub 0 or your initial amount is equal to 50 grams. Your t or units of time is equal to 5 days. Substituting all the givens, you have a new function now, that is 50 multiplied to 1/2 raised to small t all over 5. Take note, 2 is not constant. This depends on what the problem stated, just like doubles, triples, and half. Let's solve! At the initial amount of time that is equal to 0, the amount of substance is equal to 50 grams. At time is equal to 5, the amount of substance is equal to 50 multiplied to 1/2 raised to 5 all over 5, or simply 50 times 1/2 raised to 1 is equal to 25 grams. At time is equal to 10, the amount of substance is equal to 50 multiplied to 1/2 raised to 10 all over 5, or simply 50 multiplied to 1/2 raised to 2 is equal to 12.5 grams. At t is equal to 15, the amount of substance is equal to 50 multiplied to 1/2 raised to 15 all over 5, or simply 50 multiplied to 1/2 raised to cube is equal to 6.25 grams. For our exponential model for this equation is equal to Since our exponential model for this problem is equal to y is equal to 50 multiplied to 1/2 raised to t all over 5, our amount of substance is equal to 50 multiplied to 1/2 raised to 30 all over 5, or simply 50 multiplied to 1/2 raised to 6 is equal to 0.7812. Compound interest. If a principal P, which is your initial amount of money, is invested at annual rate of R, compounded annually, then the amount after T years is given by A is equal to P multiplied to the quantity of 1 plus R raised to T. Example, Aling Junisha deposits 10,000 pesos in BDO that pays 3% compound interest annually. Define an exponential model for this situation. How much money will she have after 11 years without withdrawal? Solution. At time 0, we have initial amount of money that is 10,000 pesos. At 1 year, we have a computation that is 10,000 multiplied to 1 plus 0.03 raised to imaginary 1. Simplifying our quantity, we have 10,000 pesos multiplied to 1.03. Simplifying our term, we will now have the answer 10,300 pesos. At time 2, we have 10,609 pesos. At time 3, we have 10,927.27 pesos. Let's compute Aling Junisha's money after 11 years. For our solution, we have an equation that is A is equal to 10,000 multiplied to the quantity of 1.03 raised to 11. Simplifying our equation, we will have the answer 13,842.34 centavos.
Let us have another lesson through an activity. And your activity is identify the following if it is an exponential function, exponential equation, or exponential inequality. Perfect! It is exponential inequality. Good job! It is exponential equation. Perfect! It is exponential inequality. Correct! It is an exponential function. Good job! It is exponential equation. Correct! It is an exponential function. Perfect! It is exponential inequality. Correct! It is an exponential function. And that's our lesson for this episode. I hope that you learned something new today. I am Sir Kim, leaving you a challenge that in this middle of difficulty, there is always an opportunity. Bye!